daily challenge. Today, we're just gonna be going over a few problems that you guys submitted yourselves. I see a lot of great discussion in chat already. This is awesome. I think a lot of people are saying there was like pi digit reciting competitions and somebody got like several hundred digits, which is awesome.
Several hundred. That's crazy.
Yeah, that sounds crazy. But okay, but it's still 100. That's still a lot. All right. Just to get started off, we're all TAs here at Daily Challenge. I'm Eddie.
Hi, I'm Vivian.
And I'm Eric, and we've been TAing the Module 01 courses for you guys. And like Eddie mentioned, this is like a fun thing that we're kind of doing. We're doing problems that you submitted and some of us submitted live. We haven't seen them before, and we're about to solve them right in front of you guys. So it's gonna be a fun time.
By the way, if possible, could you guys like mute if you're not talking right now? Thank you. That would help a lot. Yeah. Wait, someone was asking where Po is. So Po won't actually be in this live stream. It'll just be us doing the problems. So unfortunately, you won't see Po. But yeah, if you've been taking the live courses, you've probably seen his face, so far.
Yeah. And you might have noticed or figured out already, we've got the chat down here. You're going to private message chat relay in your Zoom, and you'll be able to chat here. It's really, really cool. So why don't we all test that right now? Give us your favorite flavor of pie. And we're about to see a lot of messages scroll through.
I'm also interested in seeing what are your opinions on pie and cake. I know it's all about a Pi Day celebration, so there's only one right answer, but pie or cake?
I say pie is better. I like pie way more than cake. Really?
To be honest, I don't eat that much like sweet stuff in general, so I feel like I don't eat pie very often. I had I had pie in math class, pie from a guy during lunch who brought it to his math class, but he didn't get to eat it, and then pie during math club after school. So it was a lot of pie today. A day? Just in one day? Oh yeah. Man, that's a lot. We didn't do anything. Honestly, I didn't even realize it was Pi Day until I was like, oh, there's a Pi Day celebration today.
Yeah.
All right.
Well, I guess pie is a little more mathy than cake. So if I had to choose,
history teacher give me pie? Yeah, that's crazy.
Ooh, looks like everyone's figuring out how to use the chat. That's great.
Awesome. Yeah, and not every message is going to show up. It's going to be rate limited, only a certain number of messages per second is going to show up. So don't worry if your message isn't showing up. It's most likely due to that we're getting tens of messages per second right now. We're very flooded, but
yeah.
It's actually kind of like a lottery. So if you send your message at the same time as somebody else, the exact second, only one of your messages goes through. So there is a luck factor in it, but you guys figure it out as we go along. Oh, and there's stars. If you say something particularly good, our moderators working behind the scenes are going to start, and you'll be more likely to show up, and you'll get these little numbers that you can brag about to your friends. It's great.
And there are a lot of moderators today, so don't worry. You guys will be getting a lot of stars, hopefully. Oh, Rohan's asking, are we doing the most user-submitted problems? We're just going through the problems on that document that you guys might have seen. There was a document of problems that people submitted, and we're just going to go through them and live solve them.
Yeah, and then maybe we'll do something fun at the end where we put our own problems out. But yeah, I think I wrote a couple problems that were in there. I'm not sure if Eddie or Vivian did. Probably.
Yeah,
yes.
I did not contribute to any of them because I'm going to this blind. None of us have seen any of these problems unless Eric gets one of the ones that he wrote. Yeah, but we'll cover those if you end up getting it though. Yeah. But I think it is 4 past the hour.
Hey, let's go.
But I think it's time we can properly start now.
All right.
So
who wants to take the first one?
Why don't we have chat decide? Why don't we have chat decide?
Chat. Who's doing the first one? Let's see. This is a little nerve-wracking.
Wait, 722. That's interesting. I haven't really heard of that before, but that's an interesting idea.
Oh wait, that's actually really cool.
Okay, I already saw it. First message says Vivian, you're going first.
Okay. Right. I already kind of had the problem up. Okay, so this is problem number 1. Oh my gosh, this is so long. Whoever wrote this, were you trying to torture me? Anyway, So yeah, I haven't seen this problem before, so this will be a live solve. So I'll just kind of talk about how I would do it. So there's a circle with radius 15, and Wait, what the heck? Okay. So the person stands on the outside, runs to the center, and then does some stuff and comes back. So like they're basically going two ways, from the outside to the center and from the center back to the outside. Okay. And Andy runs at 10 meters per minute, picks up 5 pies each time he runs to the center. Oh, okay. And then it takes him 1 minute to eat each pie. Okay, what? Jenny runs at 3 meters per minute and can pick up 10 pies each time she runs to the center. However, it takes her 2 minutes to eat each pie. How many total pies can they eat in 2 hours? Okay, what? Wait, this is like low-key kind of hard. Okay, so first of all, the radius of the circle is 10 meters. Okay, you know what? I'll just like compute the rates at which each person like eats pie and gets pie. Yeah, you guys are right. It's a lot of operations, but okay. You guys are saying it's doable, so I'll do it. So Andy picks up 5 pies each time he runs to the center. So, okay. Basically, for each one of Andy's trips, one trip for Andy takes how much time? So in order to go to the center and come back, that's 30 meters. Since Andy runs 10 meters per minute, that would be 3 minutes of running. 3 minutes of running, but then he also eats pie, right? So how much time does it take him to eat pie? 1 minute to eat each pie. So one trip for Andy is 1 minute running plus 1 minute of eating pie. Is that it, or did I forget something? Oh wait, no, it doesn't say that he takes time to pick up the pies. So wait, hold up.
He takes 1 minute to each pie.
Okay, I see. Yeah, I messed up. So one trip for Andy takes 3 minutes running, but since there's 5 pies, he takes 5 minutes for eating, I think, because there's 5 pies and he needs to eat all of them. So it's 3 minutes running, 5 minutes eating, and 5 pies eaten. So basically, Andy is 8 minutes for 5 pies. That's like his rate of like pies per minute, basically. Okay, now let's look at Jenny. How fast does Jenny eat pies? Let's see. So Jenny runs at 3 meters per minute. So in order for her to go the entire 30 meters, so Jenny must take 10 minutes of running, I think. 10 minutes of running. Since she has 30 meters to cover and she runs at 3 meters per minute, so that will be 10 minutes. And then she picks up 10 pies and it takes her 2 minutes to eat each pie. So that would be 20 minutes of eating, I think. And 10 pies eaten. So Jenny's rate is 30 minutes for 10 pies. And yeah, I'll just abbreviate her name, Jen. And then Andy was, I think, 8 minutes for 3 pies. Okay, good. Looks like people are agreeing in the chat, so I guess I didn't do anything horribly wrong. Now let's see if I can finish the problem correctly. Looks like people are saying 115. Okay, let's see if I can get 115. So they have 2 hours. Oh, I see. So they have 2 hours. 2 hours equals 120 minutes.
Wait, Vivian, double check. I think Andy eats 5 pies, so it should be 8 minutes and 5 pies.
Wait, yeah. Okay, sorry. Yeah, that you are so right. I don't know why I wrote 3. I meant to write 5. Thanks for catching that. So 120 minutes, then Jenny should have 40 pies, and Andy should have 75 pies. And I got these numbers because, let me just make a bit more space. Because if Jenny eats 10 pies, wait, this is like, there's like no space. But anyway, if I like, I'll just circle like the rate kind of. So Jenny Jenny takes 30 minutes to eat 10 pies. So if we have 120 minutes, then 120 equals 30 times 4. So you take each of those like 10 pies in 30 minutes and get 4 of them. And then she gets like 4 kind of batches of 10 pies, which is 40 pies. So that's how I calculated the 40 and 75. And then I guess you just add them and get 115. People are saying they're slow runners.
I mean, you wouldn't be very fast if you just ate 10 pies either. You'd be more like
That's
12.
exactly what I was gonna say.
Wait, hold up, that's true.
I like this problem is like not realistic, but it's also very realistic if someone just ate 115 pies. So
No, I don't know if this is related, but I know that the world record for the most amount of jelly-filled donuts eaten in 1 minute is 2. So like even the best can't handle that much like sugar. So like it's pretty reasonable. They're doing their best.
I guess like jelly donuts are like really dense, like compared to stuff like bread and
Yeah.
Yeah, I
All
really
right.
have no one tries this
115. Oh, Danya says, how big are those pies? That's a very good point. We need to consider
Yeah.
that.
These
All
are
right.
mini pies.
Yeah.
hopefully they're the mini pies, the little tiny ones from McDonald's, those apple pies.
Okay. All right. I'll take the next one. What do we got? We got one of your problems, Eric. All right.
This is mine. Oh, I love this.
Is this gonna be painful for me? All right, this is pretty short though. It's not as painful as last time. All right. Cylinder is height 4 and a base radius of 12. A cone is constructed with the same base radius and same total surface area. What is the height of the cone? Oh boy. Okay, I thought it was gonna be one of those problems where it's same base, same height. But no, you decided to make it harder. So
You know what was harder? Coming up with the numbers so they'll actually work out to be very like nice integers on the
Dude,
left.
I'm sure you did that very, very quickly. You're very
It did not. It was
okay.
at like 11:30 p.m. It was not fun.
So we have base radius 12 and a height of 4. This is drawn very poorly to scale, but that's okay. So we're given that a cone is constructed with the same base radius and the same total surface area. Well, I think it'll help to first just find the surface area of the cylinder. In which case, if we think about a cylinder, the top and the bottom are circles. That's not the hard part. It's how do we get this weird circular, flat part? How do we find the area of that? But if you really think about it, this like flat part is just a bunch of straight lines. And if we unravel all the straight lines, it's gonna be, so if I do, let's mark the straight part with like, let's do orange. So if this is orange, we want all the flat part, right? So if we unravel that, it turns out that it's a perfect rectangle. And that this top edge of the rectangle is exactly the circumference of that circle, which we know is 2 pi r. And in this case, since the radius is 12, I guess the width here would be 24 pi, and the height would be the same height as a cylinder. So that means that the surface area of just the lateral part is going to be this rectangle. 4 times 24 pi gives me 96 pi, right? But we're not done yet because we need the area of the 2 circles on the top and bottom as well. But that's just a simple pi r squared on both sides. And since the radius is 12, you'll get that one of them is going to give us 144 pi. But there's 2 of the circles. So 2 of them together would give me 288 pi. And so with the lateral part and the 2 circles combined, we get 288 plus 96, which I believe is 384 pi. It looks like a nice number. So maybe, okay.
Yeah, it is.
All right. And then for the surface area of a cone, this is a little probably more unknown because a cone, while we do have the circle base, so we know this is also 12 from the problem. It doesn't look like 12. 12. This little weird sector is a lot harder to find out. So the surface area of a cone, just the lateral part actually, is pi r L. What's L? L is the lateral. Well, it's the slant height. That's what it's called, the slant height. So you would have to add both this, weird curvy part plus the circle on the bottom. Wait, I'm doing this correctly, right? I think.
Yeah, I think.
I'll check.
I think
Okay.
so. The idea is like the lateral part of the code. Sorry, I'm kind of drawing the chat, but it's fine. I mean, instead of a rectangle, it unravels to be a sort of like a pizza shape or a pie shape because it's Pi Day, right? It's sort of going to unravel to be something like this. And so this outside area is going to be the circumference of the bottom circle here, and this length is going to be my my L, the slant height, like Eddie was mentioning. So that's actually how you get to that formula there. But yes, this is kind of the hard part of the problem.
Yeah, this one is
Thank
a
you
little
for
bit
that
on the
reminder.
harder side.
Awesome. All right, so from here, that just the pi RL only covers that wavy part. So we need to first, we know that the total surface area of this cone is going to be first the circle on the bottom, which is 144 pi, as we did before, plus the pi RL here. And so if this plus the slant height, well, the curved part of the surface area, I guess, equals 384 total, then I know that just the pi RL is going to be 384 minus that, which gives me pi RL is equal to 384 minus that is 240 pi, right? Okay, and so from here, we just do algebra. We know that r is equal to 12 and pi cancels out first of all. So pi, divide pi from both sides. And since r is 12, we divide 12 from both sides, you get 20. So the slant height is equal to 20. And now I do see, yes, you did pick very, very nice numbers, Eric, because with a slant height 20 and a base, well, I guess the radius 12, this is just a right triangle because the height is perpendicular. So we have a 12, 20. This is a well-known 3, 4, 5 triangle. 12, 20. The last side is 16. So I'm getting C16. Did I mess up?
Oh, that was correct.
Yeah, given
Okay.
that it worked out so nicely.
Because I think I saw the r equals 24 on Vivian's screen earlier and I got really scared. I was
Okay,
like,
no, I did the math wrong. I somehow got 240 divided 12 is 24. Well, good thing that you didn't mess that up.
Yeah,
Oh,
you
no.
also notice that I put 20 as an answer choice just to trip people up. If you
That is very smart, yes. But make sure you always read the question. Ask for the height. So
Yeah.
very good. All right. On to you, Eric.
all right, let's see what I have in store for me. Let me move.
Is that another one of your problems, maybe? Nope.
Hopefully, I don't think it is.
No, this is neither of our
Oh,
problems.
okay, I see. So this problem, no answer choices, very sad day. On Pi Day, Andy, Bob, Carl, and Dylan make a special pie. They divide the dough into 4 shares, and each of them takes one of them. Okay. Then they make their dough into one big pie, which is a flat circle shape with constant thickness. Okay, so they take 4 pieces of dough, and then they combine them into one big circle. Each one of their pieces has pi square inches of dough. What is the radius of their pie? Wait, so
You got lucky.
although the wording is interesting, to say the least, but I'm not entirely sure what the problem is trying to say. Pi
Wait,
square inches of dough? That's weird because volume should be measured in cubic inches. Are they talking about surface area?
Maybe wait, this is weird. Maybe they're assuming that like the thickness is like 1 or something. I'm not sure.
Well, if the thickness is what? They make their dough into one big pie, which is a flat circle
I
shape.
think maybe they meant volume, and yeah, actually I'm pretty sure they assumed that like the height of the pizza or whatever or the pie was 1, because it would make sense like that.
Oh, what if, okay, I think what the problem is, okay, I got it. I think what the problem is trying to say is that the top surface area, like each one of the pieces contributes pi square inches. So my top surface area for the entire pie is going to be 4 pi, which means the radius is going to be 2, because pi r squared equals 4 means r equals 2. Because if they're referring to volume, we don't know the height of the pie, which means we can't actually find out the radius. So I'm pretty sure that's what the question is asking for, and that's why my answer is going to be 2.
Looks like everyone in chat is saying 2, so
2.
Yeah, they're all saying it's a 2D pi.
It's a theoretical pie. It's in flatland. You know, you got the polygons all moving across, but that was quite an interesting problem.
okay, that was interesting.
All right.
Well, I guess it's my turn now. I hope I won't get one of mine. Okay, no, this is not one of mine. Interesting. Another semi-long one.
Watermelon
Okay.
pie mart.
Yeah, wait, watermelon pie? I never heard of that.
Do they
Interesting.
just only sell watermelon pies now? Are those even a thing? I will want to try
I
one of those.
didn't think they were, but that sounds kind of interesting. Okay, cylindrical pies and spherical watermelons. Okay, I see. So a watermelon and a pie. The radius of the watermelon was 1 inch larger. So this is my bad drawing of the watermelon. The radius is 1 inch larger than the radius of the pie. So the pie is like this, I guess. And this is like one more than that. Okay, and the volume of the pie is 16 pi. Oh, interesting. And the radius of the pie is 4 times the height of the pie. Oh, okay. So since they told me this nice like variable kind of relationship thing, I know that the radius is 4 times the height. So I'll just write the radius as 4h and the height as h for some variable h. And I can also write this radius as 4h plus 1 because it's 1 longer than 4h. Okay, and then it tells me that the volume of the pie was 16 pi. Interesting. So using cylinder volume formula, I get that the volume is h times 16h squared equals 16 pi. Oh yeah, and times pi to this. Oh, that's kind of nice because it just becomes 16h cubed equals 16. And so h is 1. And yeah, okay, now what do I want to figure out? So I want to figure out the volume of the watermelon. Okay, great. So I have like everything that I need to know. Now I just have to like do calculations because I know that h is 1, so I can compute the radius of this spherical watermelon. If h is 1, then 4h plus 1 equals 5. So now we just have to use the spherical volume formula, which is, I think it's 4/3 pi times the cube of the radius. So it would be 4/3 pi times 5 cubed, which is 5 times 125, 5 times 125, wait no, 4 times 125, which is 500 over 3 pi. So 500 over 3 pi, and then I guess n would just be 500 then. I hope I got that right.
That seems right to me. I'm pretty sure some people in chat said it's right as well.
That was a pretty nice problem.
Yeah,
pretty
watermelon
intricate.
pies.
We got what?
Oh,
2D
watermelon.
pizza dough, watermelon, spheres, cylinder pies. This is a very pie day.
It's very math counts like probably for something like this. But I am going to take the next one because the one after that is my problem that Eddie's going to
Ooh.
take.
I think you're
Yeah.
just setting me up.
All right, there's an entire diagram included. Wow, they put a lot of effort into this. A snail is crawling along the spiral shown from A to B. The spiral consists of 5 semicircles with alternating centers. Okay. The smallest semicircle has a radius of pi meters, and the speed of the snail is pi meters per hour. After how many hours will the snail reach point B? Okay, so the snail is actually running faster than the people from the first problem.
Is that why they were saying that like they were slower than the snail?
Is
Oh my
it?
God.
I'm not actually sure, but anyways.
Okay.
The first thing I noticed about this problem is that I'm going to scale everything down. So imagine I just make everything smaller, right? So now the smallest semicircle has a radius of 1 meter and the speed of the snail is 1 meter per hour. Now before you guys like do anything like this, you have to be really careful with dimensions because a common like trap is to assume that say a cubic yard is 3 cubic feet. That's not true. A cubic yard is 27 cubic feet because each dimension is going to be scaled by 3, which means that my total volume is going to be scaled by 3 times 3 times 3, which is 27. Anyways, the point of this is I'm going to make sure that the only thing I'm going to deal with is lengths and not areas. And since the only thing I have to deal with is length, speed is length over time, which means that I can do this without, screwing up. So I'm just going to assume the snail has a speed of 1 meter per hour and the semicircle has a radius of 1 meter. That makes it a lot easier. Sadly, it does get rid of the pi, but I'm sure it's fine. So now let's find how far the snail is going to travel from A to B. So the smallest semicircle, let's see, am I drawing the right place? The smallest semicircle is going to have a radius of 1, and it's a semicircle, so its arc length is going to be pi. So normally it'd be 2 pi, but it's half a circle, so we divide, it's pi. Then the next circle is going to have a radius of 2.
Ooh, wait, Max brought up a really good point in chat. So he says, because you scaled it, scaling it doesn't affect the time, because I can go
Exactly.
twice as fast, but in twice the distance, it doesn't matter. It's still the same time.
But yeah, true. Good point.
Great point.
That's an even better point. I like that. Yeah. And then so the third circle, this one. Oh, you can't see me. It's above my hand. It's fine. That one is going to be 3 pi plus 4 pi plus 5 pi. So in total, the snail is going to go 15 pi meters. It's also, I'm pretty sure, will take 15 pi hours to reach point B. See, I think people were saying 30 pi eats per hour.
I think
15
15.
pi, yeah. Gentle Deer is agreeing with me. Only by 100 times. Yeah, we are only faster than snails by 100 times. Only. What else? Yeah, 15 pi hours. That's pretty simple. I like it. I like it.
It's really nice that like there's an arithmetic progression of like the semicircle arc lengths. Like you don't really have to calculate each one once you realize there's a pattern.
Mm-hmm.
Yeah, that's interesting. I wonder if there's a faster way or a simpler way. But
I
anyways,
don't think so. But,
Quality problem overall. I think just finding the arithmetic sequence is already a huge shortcut.
yeah.
All right. Well, on to your problem, I guess, right? I feel like you're bound to get me one of these problems. All right. We have ancient Greeks, of course. They were responsible for a lot of the math we deal with today. Ancient Greeks were able to approximate pi by inscribing and circumscribing circles with regular polygons of increasing side numbers. Suppose you inscribe and circumscribe hexagons
Oh, hey, this one isn't too
in
bad.
and around a unit circle. What is the positive difference between the area of the circumscribed hexagon and the inscribed hexagon? All right, did this, okay, did say unit circle. Okay, so the circle, unit just means it has radius 1. How well can I freehand a circle? No, no. There we go. You know what? Muscle it, like, you know what? Close enough. Okay, so we have a circle radius 1, and then hope that I can draw a hexagon. You know what? you know what? This isn't bad. I'm using the straight edge. This is pretty accurate, actually. Whoa. Okay, what's the best way for me to draw the outside hexagon? I'm gonna do it so that the flat edge hits that. And so it's gonna look like this. Uh-oh. Okay, that took a while. You know, okay, no, this needs to be longer. Oops. You know what? More or less, this is a hexagon. And then, so from here, we just have to express the side length of a hexagon somehow using this knowledge. Well, in general, we can utilize the fact that a hexagon is really just 6 equilateral triangles. I don't like hexagons this way. A hexagon is always just 6 equilateral triangles. And so as long as we have like this side length, for example, that's just the side length of this outer, this side length of the equilateral triangle is actually the side length of the hexagon as well. And on top of that, if you guys don't know, equilateral triangles are really nice because they're 60 degrees. They all have 60 degrees, which means if we split it down the middle here, we end up getting a right angle. And we can deduce that this is 30 degrees, but you can also think that we split the other 60-degree angle in half. So you have a 30, 60, 90 triangle. So for example, if I have a side length S, then after splitting this side in half, just this portion is going to give me half the side length, or in other words, S over 2. And also using the ratios for a 30, 60, 90 triangle, we know that they go 1 √3 twice as long. So this means that the height, since the S over 2 is the short side, it's opposite the 30-degree angle. The side opposite the 60-degree angle, which is the height, is √3 times as much. So the height here is going to be √3 over 2 times S. And from here, if I multiply these two, I'm just finding the area of the entire triangle. But if you want to think about it, multiplying these two together gives me the area of the rectangle, which is really just the entire triangle, because I can put this triangle and fill it in the rectangle there. All right, so this means that we get √3 over 2s, which is the height, times s over 2 is, oops, that goes over the problem. Let's do yellow. So root 3 over 2, that's orange, oops, times s over 2 gives us root 3 over 4 s squared, which means for any equilateral triangle, as long as it has side length s, this is the formula, which means I'm going to use this shortcut from now on to find the area of these hexagons, because it's going to be much easier with this shortcut. All right, so right away, I see that this radius 1 on the circle is actually the side length of one of the equilateral triangles. So the length, the area of the hexagon, well, so the side length of the hexagon is 1, which means the area of one of these equilateral triangles is root 3 over 4 times s squared. S squared is just 1 because the side length is 1. But a hexagon is 6 equilateral triangles. So the area of the blue hexagon is going to be 6, I'm going to move this over, 6 times root 3 over 4, which means it's 3 over 2 root 3. Now, looking at the big hexagon. So I just have to find some way that it's related to 1. Now, if you notice, if I draw this equilateral triangle in the hexagon, 1 happens to be the height of it. I'm going to actually, it's blocking my face. So goodbye, equilateral triangle. Okay, so that's the height of this equilateral triangle. And again, we just talked about 30, 60, 90 triangles. So this is the 60-degree angle. That's a 30-degree angle. That is the 90-degree angle. So here, 1 is equivalent to here. It's the height. It's the side opposite it's the longer leg. It's the side opposite the 30-degree side. So it's the opposite of what we were talking about. The length of the short side is going to be root 3, like a factor of root 3 less than the height. So in other words, this side length is 1 over root 3, because the ratio is the longer leg is root 3 as much. And so we got to make sure to keep that, since it's still a 30, 60, 90 triangle. And then from here, since we want the side length of the hexagon, that's twice that. So you get 2 root 3 for the side length of that hexagon. And for just this equilateral triangle, again, we can plug this in. So this is s is 2 over root 3. So s squared is going to be this squared, which is 4/3. So I have root 3 over 4 times 4/3. Cross out the 4s. This is root 3 over 3. And since we have 6 of these equilateral triangles in the hexagon, there's 6 times that. And 6 over 3 times root 3 is going to give me 2 root 3. So the difference is just going to be 3 over 2 root 3 minus 2, 2 root 3 minus 3 over 2 root 3. In other words, that is just root 3 over 2. And that's my final answer. It should make sense, because if you look at the diagram, it looks roughly
Wait, hold
accurate.
up. The question was asking for a difference in areas.
Yeah, I think I did that, right?
Yeah, well, I'm asking you, how accurate is your approximation of pi? Because actually, this is how they use it. Because the area of the circle is actually going to be exactly pi. So if you have more and more polygons, you're going to get closer and closer to pi. I think Archimedes went up to like, what, 96, and he got really close. I'm only asking you to do a hexagon. So
yeah,
you should be thanking me.
I think just looking at it though, like if you see the gap in between the hexagons, like sure, maybe that like root 3 over 2 is like just under 1. So it would be like, if you piece all the gaps together, it would be just under a square of radius. Of side.
Wait, you know what? I saw the problem completely wrong, because I drew the 2 circles around the hexagon instead of the other way.
No.
No, I did a different problem. But anyway, here's a big solution to a completely different problem.
Yeah. And I also, while Eddie was explaining, I saw someone like come up with a really clever solution in chat. Instead of finding the areas of the hexagons individually, I don't have a diagram. I'm not fast enough to draw it right now. You can look at Eddie's screen. But they found the areas between the hexagons directly, because there's 6
I see. Okay.
triangles, and that
I'll
actually
try
is
and do
way
that.
faster.
Okay, I will try that. That's actually smart. So basically, the solution is saying, well, if you notice, for each of these triangles, there's 6 of them. So the difference in between the two is actually these 6 triangles. So if I just find one of them and multiply by 6, we're done. And so if you notice, the bottom side length here is just the side length of the blue hexagon, which is just 1, because that's also the radius of the circle. And then again, this is just a bunch of 30, 60, 90 triangles. So here, if I were to just take here, let's do this. What's another color I have? This is going to show up well. It's like kind of magenta-ish. So I just take this magenta triangle. It's getting really messy now. I'm just going to clear everything. If I just take this magenta triangle, we just discussed that this was half the side length of the blue hexagon. So this is 1/2 because it was 1. And since this is also 30, 60, 90, since this is the long leg, that's going to be √3 less. So this is going to be 1/2 √3. And we multiply that, 1/2 times 1/2 √3 divided by 2. Wait a minute. Okay, yes, this does make sense. Wait. Okay, I feel like I did something wrong. Okay, anyways, this is the area of just this triangle. Actually, I don't need to divide by 2. Yeah, because originally it was this whole triangle. And so we don't need to divide by 2. To find the area of the whole original triangle, which was the pink shape like this, I just multiply these two because it's like finding the rectangle from earlier. So you get 1/4 √3, and we multiply this by 6. And in turn, you get, this is not the same answer. Wait, never mind. It's because the denominators are not the same. So if you want to rationalize the denominator, you multiply by √3/√3. √3 times √3 cancels out with 3, and you end up getting 1/2 √3.
Same answer, yeah. And that evaluates to what? It's like 0.85 something. Not very good approximation, as you can tell, because like the hexagons aren't perfectly going through the circles. But you know, if you go higher and higher, you know, maybe we should do a dodecahedron at the end of class. Dodecagon.
We could just derive a formula for any side length. How about that?
I don't know if that's well, you would need trig for that, but
yeah. All right.
Yeah,
anyway.
Okay. I think it's my turn next.
It is.
Fellow Eric.
That's not me, by the way. That's a different Eric.
Oh, okay. Another pi. Okay. And there's answer choices this time. That's nice. So we have a cylindrical pi, and the height is 3 less than the radius. So the height is like h, I guess. I just like the variable h. And then the radius is h plus 3, I think, because the height is 3 less than the radius. Yeah. And oh, interesting. So this just gives you the volume, and you want to find h basically. And then you can find the surface area using that. So I need to make an equation. The volume of the pi is going to be h times h plus 3 squared pi. Since the volume of a cylinder is like the thickness multiplied by like the cross section area, which just looks like a circle. So we have h times h plus 3 squared pi equals 108 pi. Now, if you expand this, you would get like a cubic equation, which I don't really want to do. So I'm just going to guess values of h because it doesn't seem too hard. I think h is 3 because like 3 times 6 squared equals 108. So yay, it is 3. That was easy. Okay, so I guess that means that the height is 3 and the radius is 6. I'll just rewrite that. The height is 3, radius is 6. And now we want to find the surface area of the pi. Okay, I'm assuming we're counting like the top and the bottom, and also like the lateral surface area. So let's do it by a different section. The lateral, which is like the part around it, is going to be equal to the circumference times the height, which is 12 pi times 3, which is 36 pi. And the top is going to be 36 pi because it's just a circle with radius 6. And wait, hold on. The bottom is also 36 pi, which means that the entire thing is just 108 because 36 pi times 3. So it's the exact same number that was in the beginning of the problem. We just hid the answer up there. Interesting. The surface area is the same as the volume. That's kind of cool.
Coincidence, or is it just okay?
That is definitely a coincidence, but
all right. Who wants to take the next one? Do you have any more questions in here, Eric?
No, I think
I have one. Okay, I technically have one more, but they like changed the entire problem, so it's not even fun anymore. So
too. Huh.
I'm pretty sure it doesn't count as my problem anymore.
Yeah.
Wait, is it this one?
No, that's not me.
Oh, okay. Do you want to take it then?
All right, let's try this. So Cirques and Pi are friends and they decide to go running. I don't know why you would want to do that, but together they're running on a circular track, start off simultaneously, but Circe quickly runs ahead. If the ratio of Circe speed to Pi speed is 3:1, and the radius of the track is 20 meters, then how many meters would Pi have run by the time the two meet for the third time? Okay, so here's an interesting observation I thought of. We don't actually care about how fast they run because at any point in time, C is always going to have run 3 times the distance that Pi has run. We don't actually need to find out how fast either of them are actually going. We just need to know that Circe has traveled 3 times as much. And this is important because this can save us in defining a lot of variables and save us chances to make mistakes. So if Pi's distance, I'm writing on my chat, hang on. Pi's distance, and the letter be D, and then I don't know how to pronounce it. Sark?
I'm going with Circe as well. Yeah, that's what I was thinking.
It's okay. I don't know if it'll count as a long I because the E is at the end, but it's I don't know.
definitely not.
Okay, I will investigate while you solve the problem.
All right. C, I'm going to call it C for now on, is going to go 3 times that distance. And the other observation is that by the time the two meet for the third time, C has run exactly 3 more laps than Pi has run. Exactly 3 extra laps. The first time she has run 1 extra lap, 2 extra laps, 3 extra laps. You can kind of think of it if Pi was just sitting there stationary, not running at all. And then the third time C would meet them is when she has obviously run 3 full cycles. So we know that 3D minus D is going to be 3 full revolutions of the track. Well, the circumference of my track is going to be 2 pi r, which is going to be 40 pi. So 3 times that is going to be 120 pi. So 2D is equal to 120 pi. D is going to be equal to 60 pi. And we're asking for how many meters Pi would have run, so that's just our answer right there. Does that seem right? I'm always worried about making some dumb mistake at the end.
I mean, okay, that looks right.
I was investigating the origins of Circe. So a verdict is that it is pronounced Circe, and
That's so weird.
I don't know. She's a enchantress and minor goddess in Greek mythology. She was a powerful sorceress who turned people into swine.
I think Pi should be careful.
That's true. You never know. One wrong
training so you can outrun Circe, you know?
Yes. Although it looks like I think Pi is losing pretty badly.
Yeah,
hit the gym, leg day.
Oh no, wait. Why do I keep getting your problems?
Wait, what? Oh.
Next
well,
one is.
I didn't get it.
All right. A wise lobster is making pies. Oh no, this. This is an awesome
the
reference.
answer is.
This is great. Oh my god. All right, they're all perfect cylinders with height 1 inch. She uses 1 gram of sugar for every 144 cubic inches of pie. How many grams of sugar does he need for a pie 1 foot in radius? All right, this doesn't seem too bad. What color do you want a pie? I'm gonna take the time to decorate this one. So reasonably, a pie would have a brown crust, yeah. So I think I did this right? So this is brown, but it's perfectly cylindrical. So I don't know how reasonable a pie can make this. What did it say? Height 1 inch. So this is 1 inch. And then what type of pie do we want to make this? Like I can,
Wolfie says a green pie.
Blueberry pie? I don't know.
I was talking about watermelon pies earlier in one of the problems.
Yeah, here, I'll do what is it called? I forgot what these are called, but like the nice patterns on top. Anyways, so 1 gram of sugar for every 144 cubic inches of pie. So let's figure out how much pie there is. What's the radius? Oh, 1 foot in radius. Well, I don't like 1 foot because I'm dealing with inches, right? So to express the radius, I'm going to say this is 12 inches. And for 12 inches, now we're good for finding the volume. Volume is just base times height. And for a cylinder, and the base is going to give us 144 pi. I think we all know how to find the area of a circle by now. And then multiplying by the height, it's just 144 times 1, which is still 144. How nice. Okay, so this turns out that we have 144 pi cubic inches of pi. and it uses 1 gram of sugar for every 144 cubic inches of pie. So that means for 144 pi cubic inches, and every 144 cubic inches, I use 1 gram of sugar. This is just saying I need pi grams of sugar. So he is going to
Yay.
use pi grams of sugar. I'm trying to visualize this. How much is 144 cubic inches? So like,
Okay.
how much is it? a cubic
Well, you
inch?
can think of it like a pie, right? Like 1 square foot and then 1 inch thick. Kind of like a pizza box. It's actually basically
It's actually a pizza box. So a pizza box, an entire pie the size of a pizza box, and you got 1 gram of sugar in there. I mean,
no, it would be like, because it's 12 inches as the radius, so it's
It would be
24 inches as the
40.
diameter. So it's actually an extra large pizza box
Extra
with 1
large
gram of
pizza.
sugar.
You know what? We just have to hope that the blueberries we're using are really, really sweet and are like just, you know, so great and fresh
Yeah.
that it makes up for the lack of sugar.
We're on a diet. It's called diet pie. You know, Diet Coke with diet pie now.
Very
Diet
low
pie.
sugar pie.
0 calories.
Awesome.
It's actually a
Oh
lot
my
of
gosh, lobsters? Is the wise pie making lobsters now? What?
Wow, they're very wise. They don't want to get diabetes, you know.
Yeah.
Do lobsters get diabetes?
I will investigate.
Well, maybe it solves her problem, huh?
Oh, this is my problem? Okay.
What's
Oh,
your
I have to graph circles in the coordinate plane. Okay, this is kind of interesting, actually. So, well, first I'll just like look at the equations and like see about how to draw them because like I need to know where the vertex is or where the center is and stuff.
I
So-
think the answer choices are messed up for this one. Because
Oh,
first of
really?
all, they're not in radical form at all, even though question.
Wait.
It's just a prank. It's just a
Wait.
prank.
Wait, these look exactly like Eddie's answer choices for that one problem.
That's my
Yeah.
answer. So yes. How about we just all ignore that? Like,
All right,
Yeah.
make it a short answer problem.
Okay. So I'm just gonna look at the two equations. The first one seems like it has center at 1, 2 and radius 3. I got 1, 2 just by looking at this like 1 here and the 2 there. Cause yeah, that's just basically the circle equation. And yeah, the second one has center -4, 3 and radius 4. Okay, I'll attempt to draw this. Hopefully I didn't mess this up. Was it 1? Oh, hold on. 1, -2. Okay, good thing I catch that. Yeah, we don't want to draw it in the wrong place. So 1, -2 and radius 3. That looks correct. -4, 3. Okay, yeah, looks correct. So I'll pull out my coordinate plane.
While you're drawing that, I'll bring out the verdict. So crustaceans, I believe, cannot get diabetes. And every time I searched something up, it was like, oh, does eating seafood, is that good for diabetes or whatever? So no, lobsters cannot get diabetes. I imagine just because their biology is entirely different. But anyways, back to circles.
Wait, hold up. This is so weird. I'm getting that like the circles intersect. Maybe I'm doing something really wrong, but like, wait, hold on.
Wait.
Wait, that does make wait. So the distance between the centers is going to be 5√5, right? But
Yeah,
the
5/2, 5/2.
some of their radii. 5/2. Yeah. Sorry. I
Oh,
misspoke.
wait, hold on. No, they don't intersect. They almost do, but they don't. Yeah, that's the smart way to do it. Okay.
Oh, because 5/2 is like roughly 7.
It's a little more than 7.
A lot,
Yeah,
yeah.
because it's 1.414 something, right? So multiply by 5, 7.07 something.
Yeah, anyway.
Wait, so they do intersect.
No, they don't. 7.07 is slightly bigger than 7, so they actually just barely touch.
Oh, yeah, sorry, I went the wrong way. My bad.
Yeah.
So the distance between centers is the square root of 5 squared plus 5 squared, which is the square root of 50, which is just barely over the square root of 49. So they do not intersect. By the way, the square root of 49 is important because, okay, ignore this diagram, it's wrong, because the two circles have radii 3 and 4. So like the distance between their centers, if it's more than 3 plus 4, then there's going to be a little gap here. If it's less than 3 plus 4, there's not going to be a gap. So, but we can calculate what the gap is now because we know the total distance between their centers is the square root of 50, which is 5√2. And then we just have to subtract 7 to get the little gap. because this was 3 and that was 4. So the part in between is 5 root 2 minus 7. And it seems like that's the right answer, I think.
Mm-hmm.
Yeah,
the only
Rohan,
thing-
it would be very trolly.
The only thing I want to add is just if you're curious on where Vivian got the root 5 squared plus 5 squared from, if you imagine a little imaginary triangle connecting you would connect the two centers, and then imagine you draw a right triangle, then you just use Pythagorean theorem from there. And this is actually how the distance formula, how any distance works. So it's a good trick.
Yeah, even in 3D, there's a 3D version. It's
Yes.
cool. Okay, on to the next problem.
Right.
I forget who's doing it.
I think Eric. Did you have it up? I don't know, what's the next problem?
I don't know.
Oh, is it this one?
Like,
Okay, I'm down for it. These problems look fun. So.
oh wow. Okay.
Wait.
Wait. Let me get rid of my scribbles first of all.
Hold up. Consider the following cryptic. Okay. Wait. Is there supposed to be like a symbol here? Is this? I mean, I'm assuming it's addition because it can't like.
Wait, hold on. Imagine
It has to be addition because like
Yeah,
it has to be addition.
multiplication
Yeah.
is-
Maybe
Yeah.
multiplication would be way too big. But like. Okay. All right. Then assuming this is addition. Let's add a plus sign. We're adding pi plus day, and we get 3.14. So here's the thing. None of these letters repeat, so I can really just make this whatever I want. And I want to maximize p times I. So in other words, I could make day as small as possible. I just have to cater to making those two digits as big as possible, which means I'm just going to make I 9. I is 9, right? Because that's the biggest I can be. And
Wait,
for that to happen,
Are we assuming that like the letters P, I, D, A, Y don't repeat? Like it can't be
Yeah,
9.
probably. I would assume.
okay, yeah, they would have to all be different, right? So I guess that's true. I guess we can calculate for both. So if I is 9, then for 9 plus something to have units digit 4 this has to be 5. So we have I equals 9, subsequently Y equals 5, which this doesn't matter. The only thing that matters is that when I add these two, I'm carrying a 1 over here. So I have 14, and then 1 plus P plus A gives me units digit 1. Again, I can make P as big as I want. So I could make it 8. Sorry, I could make it 9, but again, digits don't repeat. So I'm going to make P 8, right? And now we're just checking if this is valid. Can I make a valid, like, I guess, solution to the cryptogram by making this 8? So this is 8. So 1 plus 8 plus A gives me units digit 1, which means this would have to be 2. A would have to be 2. And if A is 2, again, we're carrying another digit. Oh, okay, I see what's going on. So we get 11, but in order for 1 plus 2 to be 3, D needs to be 2, which means we have a repeat. So this doesn't work. I can't have P be 8 because D and A are both forced to be 2, which is not valid. At least I'm hoping that's how Harshil intended the problem to be. Makes it a little more interesting. So I know that 9 and 8 don't work, so I'm going to try 8 and 9. So what if I made I 8? So if I made I 8, then Y would have to be 6. Again, we're carrying a 1. So 1 plus P plus A, I'm going to make P 9 this time. And then, oh wait, I think I'm doing never mind, it works. Because this time 1 plus 9 plus 1 gives me a 1 and I carry over. And then 1 plus 2 gives me 3. So 98 and 216, they all have different digits. And so 9 and 8 work. So flopping these two. P is 9, I is 8, which means I'm getting 72. And absolutely, if you could repeat digits, then for sure, 9 times 9, 81 would be your answer. But I know 9 and 8 work for all digits being distinct. So that's the result I got.
Yeah, nice problem.
Yeah.
Awesome.
So it's kind of exactly the same one I wrote here, right? 99 won't work, 89 won't work, 98 does work. So that's.
Yeah,
Am I doing the next one? I think I am, right?
yeah, you
Yep.
are.
I love how someone in the chat just named anti-lobster. I must be very disappointed that they can't get diabetes. So move this out of the way. Oh no, what just happened? Okay. Wait, stop. All right.
Y'all good?
I'm good. Let the
Alright.
function pi of x be the number of ways to arrange xp's and xi's. For example, pi of 2 is 6 because there's 6 ways to arrange 2 p's and 2. Oh, okay. What is the remainder when pi of 8 is divided by 4? Okay. So this pi function actually is a special case of a much more general function that we can define. And this function is like a choose function, sort of. Yeah, and so, okay. And so this is sort of like more advanced combinatoric stuff, but we could do it. So you guys could probably follow along right now. We're given xp's and xi's. So let's just go back to the pi of 2 case so we can like see what's actually going on here. So you have p, p, I. And we want to rearrange them. I'm sorry, this is covering up the chat a little problem. And so what we've really done is instead of thinking about rearranging these 4, what if we just think about like inserting the i's? Like, what happens if I have p and p here, and so we have this here. We're going to set these fixed, and then we're going to insert my i's in between these two. You can notice that this is going to be the same case as just me rearranging all of these numbers. So if I insert them here, well, for example, I could put I over here, I could put I over here. That's equivalent to IP arrangement, right? Or I could have both i's in the middle, or both i's outside here, right? So it's kind of like a little insertion problem, right? And what we could actually do with the insertion, we could actually take this correspondence a step further, right? What we can think of is what's known as stars and bars. And you probably, some of you might have already like thought of this before, but stars and bars is kind of like, am I doing this right, guys? I think I'm going the wrong way with this.
Wait, stars and bars?
Wait, I don't think that's right. Okay, stars and bars is something different that relates to this, but my point is the way I would do this is we look at how many ways can I rearrange them if they're all different, right? So P1, P2, I1, I2. Now I think about placing them in these 4 slots, right? Well, the first one, P1, I could put in any one of these 4 slots. So 4 ways, right? So I put it here. And then the P2, I can put it any 3 ways. So for each one of the places my P1 can be, there are 3 ways that P2 can go. And similarly for I1 and I2. The issue is P1 and P2 are actually the same. So if I have I, P1, P2, I, and I, P2, P1, I, these 2 cases are the exact same because they both boil down to I, P, P, I, which means I'm actually going to divide by 2 times 1, because that's the number of ways I can arrange P1 and P2, and divide by another 2 times 1 here. Here's where this gets actually really interesting, because this function, going back to what I was talking about, like the picking thing, we can now go back to that. Let's think about what happens if instead I was picking spots for this to be, right? Because this is known as the choose function. And so we're going to denote this by 4 choose 2. This is equivalent to saying I'm going to pick 2 things out of 4 things, and they're 4 different things. So any group of 2, how many groups of 2 within 4 things is going to be defined by this function here, which is equal to pi over 2. I know I'm explaining this terribly, but probably one of the change other probably understand this better. But anyways, pi of 4 will be equivalent to 8 choose 4. There's going to be 8 total letters. I'm going to choose 4 positions for the i's to be in. So if I have 8 letters, right, I can pick any 4 of these, like 1 here, 1 here, 1 here, and 1 here, right? And I'm going to put i's in these 4, and I'm going to put p's in all the other positions. So in reality, it's just like choosing 4 positions out of 8 things, which is why we say 8 choose 4. And it's a similar formula. It's going to be 8 factorial, which just means 8 times 7 times 6 times 5 all the way to 1, divided by 4 factorial. 4 factorial. Is that right? Oh, they want pi of 8, not pi of 4. I misread the problem.
Yeah, it's kind of a lot more annoying, but it's okay.
Okay, that makes things way more interesting.
Although what the trick is, the end of the problem only asks for the remainder when divided by 4.
Yeah,
so
yeah.
Probably...
So that makes it a lot more interesting, yeah.
Okay, now here's where this gets more interesting. Because what we can do is we can consider the number of factors of 2 within the numerator and the denominator. So we're actually going to keep going with this problem. I did not realize this problem would be so in-depth. But because we're looking at the remainder was divided by 4, the first thing we might want to consider if it's even or odd. That's our first step. right? So we're gonna have to consider how many factors of 2 are within this 16 factorial, how many factors are within these two 8 factorials, and then we can put it that way. So how many factors of 2 can I find in 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9? Yes, I'm gonna be writing this all out.
Honestly, I think you can save some work by canceling out the first 8 though, right?
I guess, but okay, there's like a more general way to find this formula for factorials. I kind of want to go over that. But
Okay,
anyway,
okay, I understand. You're right. Okay, yeah.
okay, now we look at all these numbers over here. That's a very bad 16, but hopefully you get my point. Remove that farther up. Now we're going to kind of scan through this, right? Now, which of these numbers are going to have a factor 2 in them? The even numbers, obviously, right? So how many even numbers do I have? Well, I have 16 divided by 2 even numbers. And in reality, what I'm going to do is I'm going to do a floor function, because if we want to make this generalized, because if it's 17, right? 17 doesn't count, but there's still only 8 factors of 2. So the floor function just means it's the largest integer that's still equal or smaller. So the floor of 8, in this case, is 8. The floor of 8.5 is 8. The floor of negative 1.5 is negative 2. That's kind of the floor function here. So we're going to go through these. We've done this once, but we're not done, because there's numbers that are going to be divisible by 4. And they're going to contribute another, yet another factor of 2. I already counted them once, but they're going to contribute 2 or more, which means that I need to now count how many of them are divisible by 4. There's 4 of them, 4, 8, 12, 16, right? Floor function again, still not done. We have numbers that are divisible by 8. We're going to go 16 over 8. And finally, we have 16 itself contributing one more factor of 2. And there's nothing that's going to be divisible by 32, though theoretically you could keep going this infinity. And now you can see like this little pattern here. I got 2, 4, 8, 16. And that's like the fact, you can extend this formula for any factorial if you want to find how many prime factors are within that factorial. So given that, we can evaluate this. It's going to be 8 plus 4 plus 2 plus 1, which is 15. So the numerator is going to have 15 powers of 2. What about the denominator? Well, 8 over 2 is 4. 8 over 4 is 2. 8 over 8 is 1. So 8 factorial has 7 powers of 2. They're going to be squared because there's 2 of them multiplied together, which is the denominator has 14 powers of 2. So that means in the end, my number is going to have exactly 1 power of 2. So it's going to be divisible by 2, but it's not going to be divisible by 4, which means that the answer has to be C, which is 2.
A very
Awesome.
cool problem.
That was very in-depth.
It would have been a lot easier if the x was smaller, but it's really interesting when x is big. There's like shortcuts and stuff.
All right. Do we want to keep going?
Yeah, let's keep going. Wait,
All
is
right.
it next?
I believe so.
Okay. So this problem's kind of easy, so I'll just kind of speed through it. Actually, I don't know if it's easy, but it just looks kind of short. So we have a square and a circle. Okay, this shouldn't be too hard to draw. Circle in the square, not square in the circle. So the square is outside like this. Really bad drawing, but okay. Oh, nice. So the dart is thrown at the shape and lands on it, but it's a probability that it's in the outer region. So like these corners that I'm shading in. Okay, well, to do that, we just need to find area of wanted region over total area. And the total area is easy because the square has side length pi. So the area of the square is going to be pi squared. And then the wanted region, well, we have to do a bit of subtraction for this because the total area is pi squared, but then we need to subtract this circle in the inside, which has area. Okay, this is a really weird area. Pi over 2 squared pi, which is pi cubed over 2, like Tommy said, pi squared. So this becomes pi squared minus pi cubed over 2. Oh my gosh, this is a lot of pi's. Well, I'll just cancel out pi squared from everything. So we got 1 minus pi over 2 over 1, which is, okay, is that?
I'm pretty sure it'd be 1 minus pi over 4, because pi over 2 squared.
Oh, wait, yeah. Okay. Yeah.
And the other thing you could do is probably like similar to the snail one, So I'm pretty
But-
sure people are just throwing in factors of pi to relate to pi. Perfectly fine, but basically you can scale this square down to 1 and it won't affect the probability at all. It's a similar idea.
This is kind of messy, but the answer is 1 minus pi over 4. I think. Looks about right because pi is like 3 point something, so pi over 4 would be like 0.75 or 0.8. So then it's like about 25, like about 20-ish%, which looks kind of right. Yeah.
Awesome. Yeah, I think that looks about right.
Yeah.
Awesome. Well, do we still go one more?
Yeah, let's go.
No,
Last
one more
all right.
student submitted problem.
All right, so this is our last
Let's
student
just
submit
go through
problem.
all the problems. Let's just go through all. Oh wait, we're skipping to that one?
I'll skip to
I
this
think
one
it's
since the last student one.
overtime already, so
Yeah, some students might have to leave early, so we want to make sure we can cover
okay.
this first, and then if you guys want to stay after, we'll probably end up covering the other two as well. But I actually like this one because this is about Wordle. I have a Wordle routine like every day, and there's like specific ones that I go through. This is very relatable. All right, so there's 6-digit math words, and I guess it's pretty reasonable reasoning. Like, okay, you have S, so you eventually get secant, but it's sector. All right, so we're talking about a sector, and that it describes. Okay, so the area of the sector in a circle with radius 4 is 2 pi. What is the central angle? Well, let's first draw our circle. Let's freehand a circle. Nope. There we go. All right, and so this has radius 4. Well, what does a circle of area? Sorry, a area of a circle radius 4 usually have? Well, pi r squared. I think we've done that plenty of times today. So the area of this is going to be 16 pi. But it's only 2 pi. Oh, it's a little covering. Hold up. Let me move that up. So the area is only 2 pi. So out of the 16 pi, it's only 2 pi, which 2 over 16, that's 1/8. So the sector is really only 1/8 of the whole thing. Well, how much is 1/8? We're looking for the central angle, right? So in a circle that has 360 degrees in total, we want 1/8 of that. So you divide that by 80, you get 45. So I believe the answer should be C. That was a nice incorporation of Wordle somehow.
Wait, not gonna lie, this is a pretty good like Wordle strategy. Like
I
this
know.
is pretty good.
Wait, you drew it out. Yeah.
Yeah, like it's not bad.
Yeah. Wow. That's actually pretty good. I'm honestly, Harsha, I appreciate you putting so much thought into the Wordle part of the problem. That's
Yeah,
awesome.
like these
a lot of
are
effort. I appreciate it. But it is 8 after the hour, depending on what time zone you live in.
4:38
6:59.
after the hour.
Don't go into time zones with me. I'm gonna go on a rant. Okay. Anyway, technically we are overtime because it's scheduled for 1 hour. But if you really want to stick around, we'll be here. And if you want us to go through some other problems or anything that we came up with ourselves, that'd be fine too. What do you guys think? What do you guys want to do?
Yeah. So if you guys just want to chill with us, you guys will be talking about whatever. We'll be doing the problems, and maybe we can just celebrate Pi together. But
What is this?
thank you guys for those of you who have to go for now. Thank you guys for joining. This is an awesome Pi Day
Yeah.
celebration,
Thanks
Had
for
a great
coming,
time.
everyone.
and we really appreciate your submissions as well. That was awesome. Alrighty.
Oh, you wanted the other problems? You know what?
Alright.
Instead of going over problem 14, we should go over what should have been problem 14. You know, my actual question.
Do you want to cover the circle one first?
Oh yeah, we could do the 15 first.
Okay, someone
All right,
else.
that's all up for you guys.
I'll do it. Let's see what we have in store for us. No one is gonna talk about the person who renames as Grammarly sent a Grammarly ad. I think.
Dude, they do that every time in our class. Like,
Wait, really?
Wait, hold
no,
on.
like with Vivian and I a long time ago. They were just like,
Oh.
what if like students have a lot on their plates, so like on their plates. That's how
I've
it
seen
goes.
those ads before. It's so annoying. Okay, we have some interesting people in our class too. We got people who rename themselves
Yeah,
as me, who set their background as me. Great.
You're so welcome.
But anyways, why don't we try this
All
problem?
right.
So,
Yay! For once, you get one of the problems submitted by us.
oh wow, this is Vivian's problem. Okay. All right, Vivian Mopper here. I'm very scared of what's about to be here.
Like half of the problem is not relevant at all.
4 pieces by 2 perpendicular cuts. Faust gets the 2 red pieces, while Bob gets the 2 blue pieces. Who gets more crust? Okay.
I'm also curious. Let us know. Do you appreciate the crust or not? Because for some reason, it really bothers me when people just eat the pizza and just throw away the crust. Okay, I shouldn't say that because it's implying pizza and crust are 2 different parts. But I hate it when people just throw away the crust. Why would you not eat the crust? Okay, some crust is disgusting, but most crust is good. Okay.
Okay, Vivian, first of all, I do appreciate that your legs do satisfy power of a point. Like they're actually.
Yeah. Okay. Yeah.
I'm glad that actually works out. But
Do
as
some random names there.
okay, I'm going to say okay, they're perpendicular cuts.
Yeah. That's like the one part that matters.
The one part that matters. Okay, so they're all 90. Wait, there's a theorem about this. I learned about this a long time ago. Wait.
Geometry, channel in your geometry education.
Basically, just
Wait, I just remember. Okay, there's a theorem where it says if I have a circle, and it doesn't even have to be 90 degrees, like any two like this, the sum of these 2 arcs is going to be exactly twice this angle here.
yeah.
The sum of the 2 blue arcs is going to be 180 degrees. So they actually get the exact same amounts of crust. Now, how you prove this, I actually forgot. I'm going to have to go back and look.
Right. I was thinking about the exact same thing. I'm like, how am I going to prove this? Honestly, do we want to try to live solve a proof for this?
Okay, sure.
Right.
Wait, honestly, I kind of forget too. So let's.
Yeah. Oh my God. We can all like how about this? Since all of us forgot, we can all work through together.
Wait, no,
This is
no. Wait,
perfect.
I remembered. It's literally
no.
just you do the 180 minus A minus B if those are A and B, and you just literally. Yeah.
Oh, wait, I got the proof. Okay, I got the proof.
A, B.
I got the
and
proof.
Trying to look for this angle.
I did get the
Yay.
proof. Okay,
Oh, do you
the
just-
arc length- Wait. So all you need to do is actually draw this line here. And so what this makes it so that is this angle is going to be B over 2, and this angle is going to be A over 2. That's what we're building this off of. And since this is a triangle, its exterior angle is going to be A plus B over 2. Okay, I just.
Oh yeah, I was going that way too. Okay, but I
Yay.
drew the wrong line. Okay, makes sense.
Oh yeah,
Well,
then
I-
your solution works too. Actually,
I was watching all of the comments. I appreciate all the people who appreciate cut crust. You're properly eating pizza, so that's good.
Crust is the best part of the pizza. If you throw away your crust, I can't say that here.
Way to go, self-control. Awesome, great to see.
Well, okay, why don't we go through my problem, or what was supposed to be my problem?
Okay, show us.
So
Tell-
here's what actually was in the problem.
demonstrate to us
you're
how
doing-
beautiful your problem would have been. But
So you were
hindered
doing a
by the moderators.
problem, principle of inclusion, exclusion, and you're going to draw a Venn diagram.
Oh my God. I didn't think of, I can't believe we talk about principal inclusion, exclusion in class all the time, but I completely forgot that pi would be perfect
So,
for a
what
I
you
situation.
do-
know, right?
You're going to draw 3 unit circles, and their centers are going to be spaced 1 unit apart. So basically, your center is going to be the intersection of 2 other circles. Kind of special like that.
Wait, you still have my problem on the back.
Oh yeah, I'm going to get rid of that once I finish drawing. I am currently going through these circles very slowly. There we go. Remove that. So, what is the area within 2 of these circles, but not the third? So it's basically we want. There you go. If I can draw here, here, and here. And we want the area of that. And they're all unit circles. Again, their centers are spaced 1 unit apart. That was supposed to be my problem. It was a great problem.
Who in the world is MK, by the way? Who's
I just came with 2 letters. It's fine.
Does it have to be, I saw Max Quo, he was in chat. Is
Oh,
that
yeah, I thought it actually stood for something.
Michael Kors?
Yeah.
Well, he says that people get the same amount of crust, but didn't actually say. It's because of the arc length is 180 degrees and the total is 360, so each of them get 1/2 of it.
There's other ways to do it by like rearranging like parts of the circumference, but like yeah, you guys can figure out your other ways to do the problem. It can be left as an exercise to you guys.
Yeah, we're
That's-
basically just, if you want, and it's the idea that this arc A plus this arc B added together is equal to this angle. But for this one, it's 90. And then if you notice, the other arcs added together also add up to 90. So because both of these add up to 90, they end up also proving that A plus B is also the same as C plus D.
Yeah.
So they give you the same crust.
Okay, well, it seems like that's all the problems for today, unless someone comes up with another problem for us to do on the spot. Oh,
Yeah.
wait. Wise Lobster's in the meeting? Oh my god, no!
There's a wise lobster.
I wonder if Wise Lobster saw that.
Can we?
Yeah, that's
Grammarly thing isn't really funny anymore.
yeah.
Can the average of 2 consecutive primes be prime? I don't think so, because wait, they
Oh, I mean,
Whole question?
3
Wait,
plus 5 divided by 2 is 2. So I know that's 4. Oops. Oh my God. No, I did not say that out loud.
wait.
Wait. Oh no.
wait, I feel like this is like a trick question. 'Cause
Do
I
they have to
feel
be
like-
twin primes or do they just have to be consecutive?
No, like consecutive, right?
Okay.
Wait, hold on.
Wait,
am I
no, this is, dude, of course it's troll. Think about it. Wait. The average of 2
Yeah.
consecutive primes, if they're next to each other, it's even. And then if it's 4 away from each other, it gives you.
No, like the fact that they're consecutive primes means that there's no prime between them, right?
Right. Yeah.
Like,
Oh
Yeah.
wait, of course.
Right, yeah. Because if you average them, yeah, it's gonna give some number.
I was about to go
Okay.
full mark for it and be okay, so we can stuff like that. I was about to like go down a rabbit hole. Thank you for stopping me. Wow, I can't believe you guys would do that to me. Yeah, that's not nice.
Ooh, hi, Wise Lobster. If that's actually you, wow, long time no see. We still have the pi grams of sugar quote saved, as you can tell.
Oh yes, of course.
Ooh, lobster meeting.
If I stay here for a little longer, you guys want to like chat, or if you have any other interesting questions that are
Do you have a rant
very
about time
intriguing
zones?
to us, yeah, you can tell me.
Wow, there's a trend. Everyone's renaming themselves to lobster now.
Fast, weird lobster that plays piano. Oh, you play piano. Wow, nice.
Did you have a rant about time zones or something?
What?
Time. Okay, I don't know. Time zones are
Let's
just.
not get into a time zone war. I know this is probably going to happen, but
Time zones, I mean, could be worse. I mean, you could be a programmer who has to deal with time
is
zones.
every even integer greater than 2, the sum of 2 prime numbers?
Isn't that like a special conjecture or something that's
Yeah,
so
isn't
unsolved?
that like a conjecture? I don't know. I kind of forget, but it sounds like one.
It's a twin primes conjecture. I'm pretty sure it's still unsolved. It's one of like the $1 million problems or something like that.
Okay, well, if you're actually trying to solve it, I don't think we would have an answer for you, but good luck.
Piano, cello, and saxophone?
Wow, talented.
But you couldn't spell cello correctly.
And saxophone.
Wow, that's insane.
hold
3
on.
instruments.
Saxophone is spelled correctly. Maybe.
Lobster pie is a thing?
I mean, I would think so. Like lobster pie, you know. There's pie made out of everything.
There's probably a pie. pie,
Hey,
you know?
if there's crab cakes, there has to be lobster
Yeah.
pie.
Oh, I see how it is. There's also fish cakes. There should be like clams.
There's also tomato cake.
Fish cake.
There should be like eel donuts. Well, there's jelly donuts, and there's also there's jelly donuts and there's jellyfish. Oh,
Oh, wait. There's fish donuts.